Hi, hello, welcome back to our channel Chemistry with RK. Here is our first video by using interactive display panel. So I'm continuing with our previous lecture, complex compounds, and this is our fourth lecture related to the classification of ligands. Okay. Yeah, please do support to my channel Chemistry with RK if you are new. And then I want your extra support. Please do support my channel since I'm trying my level best to give you all the concepts in an easier way. Nowadays we are in digital world, so I thought you to give all the chemistry concepts through digitally on the interactive panel. So please do support, and I want your continuous support. And then if you're new to the channel, please do subscribe. Yeah, let's move on to our lecture, complex compounds, lecture number 4. So in our previous video, we were talking about the classification of complexes, based upon certain criteria. So we have seen positive complexes, negative complexes and neutral complexes based upon the charge on the coordination sphere. And then the next one is classification of ligands. Okay, so classification of ligands is actually done in several ways again. So I have taken here, that is based upon the number of donor atoms. So based upon the number of donor atoms, ligands are classified into several types. Suppose let's say the ligand contains only one donor atom. Such type of ligands are called as monodentate ligands. Suppose let's say a ligand has two donor atoms. So such type of ligands are called as bidentate. What does it mean? Actually, the ligand can able to donate two lone pairs for the central metal atom, so that it is going to form two dative bonds. So that type of ligands are called as bidentate ligands. If suppose let's say you have a ligand which can able to form three dative bonds, or which can able to donate three lone pairs, so it is they are going to called as tridentate ligands. If the ligand donates as usual four lone pairs to the central metal atom, they can form four dative bonds. Yes, we know that the number of lone pairs the ligand is donating is equals to the number of dative bonds it is going to form. Yes. Yeah, keeping that point in mind, yes, we have several types of, I have given the classification here. Just try to have a look. So if you can see, yeah, I have given a flow chart here. So if you see the ligands based upon the number of donor atoms, if only one, so just I'll try to write down here. So monodentate ligands means they can able to form only one dative bond. Only one dative bond they can able to form. Monodentate ligands. And then when it comes to bidentate ligands, they can able to form two dative bonds. Tridentate ligands, three dative bonds. And then tetradentate ligands, 4. And then pentadentate, 5. And then hexadentate, 6. So as far as our IIT or NEET exams are concerned, we can able to end up with hexadentate ligands. Hope it is clear. So, and now let us discuss particularly about this monodentate ligands. Again, the monodentate ligands are again further classified into three types. What are they, sir? They are positive monodentate ligands, negative monodentate ligands, and then neutral monodentate ligands. Just have a look here. If we move on to our next, monodentate ligands are further classified into, yes, you can see here, the ligands which can give only one lone pair to the central metal atom. Ligands which can able to give only one lone pair to the central metal atom, that type of ligands are called as monodentate ligands. Or else we can also define that in another way, that the ligands which can able to form only one dative bond with the central metal atom. Yes, as I told you earlier, this particular definition best suits for the monodentate ligands. Monodentate ligands are further classified into three types: positive monodentate ligands, negative monodentate ligands, and neutral monodentate ligands. Okay, so let's see what are negative monodentate ligands. They are going to form one dative bond, and the ligands are going to carry negative charge on them. Such type of ligands are called as negative monodentate ligands. So just try to understand. So the monodentate ligands which carries negative charge. Yes, they are going to form one dative bond. They are going to donate only one lone pair for the dative bond formation, but they are going to carry negative charge. And now these charges, very important, these charges are going to help us to define or calculation of oxidation numbers. In the next video we are going to see the classification or the actually yes, in the next video we are going to see further bidentate, tridentate and tetradentate ligands and so on, and then after that we are going into the calculation of oxidation numbers, and then further we will proceed with the naming the IUPAC naming for the complex compounds. Okay, yes, and now there, while calculating the oxidation numbers, these charges will help us. We are going to take these charges in the calculation of oxidation numbers. Please keep that point in mind. Okay, yes. So generally negative monodentate ligands and even their ligand names, yeah, these ligand names we are going to use again in the writing the IUPAC name for the complexes. So if we have F minus is actually a negative monodentate ligand, and the name we use for that is fluorido. Oh, hope it is clear. And then Cl minus, it is chlorido, Br minus, it is bromido, I minus, it is iodido, and then OH minus, it is hydroxo. We call it as hydroxo. Okay, and then this is actually formato, HCOO minus, it is formato, and then CH3COO minus, it is called as acetato. And then next, if we move on to NO3 minus, okay, NO3 minus, we can call it as nitrato. Okay, and then CO3 minus to carbonato, and then NH2 minus, it is amido. Yes, please try to understand the differences the differences of these four. NH2 minus, it is amido, NH minus 2, it is imido, N minus 3, it is nitrido, and then N3 minus, it is azido. Very important. Yes, we are going to use these particular terminologies in writing the IUPAC name for the complexes. Okay, and then next Cn minus, we call it as cyano, and then if we talk about Nc minus, it is isocyano. And then I have given some other name for this. Okay, if you observe carefully, I have marked this cyano and isocyano, and I gave some other name called as ambidentate ligands. So what does it mean actually? Ambidentate ligands mean, the molecular formula of the ligand will be same, but the donor atom will be different. So what does it mean? In Cn minus, if you see, the carbon will be directly attached to the central metal atom. So here the carbon will be forming the dative bond with the central metal atom, whereas in Nce minus, that is isocyano, N is going to form the dative bond with the central metal atom. Hope it is clear. So from that we can understand their molecular formulas are same, but the type of the donor atom attached to the central metal atom is different. Yes, such type of ligands are called as ambidentate ligands. Again here also we can say NO2 minus is called as nitrito N, since nitrogen is directly attached to the central metal atom. So nitrogen is donating the lone pair to the central metal atom, whereas if you see the nitrito O, this O defines the donor atom actually. So in nitrito O, oxygen is giving the lone pair to the central metal atom. So both the NO2 minus and ONO minus, the molecular formula of this ion is same, but the donor atom is different. So such type of ligands are again called as ambidentate ligands. And then SCN minus, NCS minus, yes, their molecular formulas are same, but the linkage is different. Okay, the atom which is linked to the central metal atom is going to be different. Okay, yes. So such type of ligands are called as ambidentate ligands. Hope you understood very well. Okay, so please like in case if you have any doubts among these particular information or data, please drop your comments in a comment section. I will be available from now. Yes, I was planning for this digital panel from so long, so that's the reason why I am a bit busy. And then from now we are going to rock our videos. Okay, you are going to get plenty of videos from now. So okay, yeah, and then next let us move on to our positive monodentate ligands. Okay, yeah, let us move on to positive monodentate, similar to the negative monodentate ligands. So they are monodentate, but they carry positive charge here. Okay, so in the previous case we have seen negative charge, they were carrying negative charge, and now in the positive monodentate ligands they are going to carry the positive charge. So if you see NO2 minus, that is nitronium ion or nitronium we say, and then Cl plus chloronium, Br plus bromonium, and then NH3, NH2, NH3 plus hydrazinium, and then NO plus, it is nitrosonium. Yeah, and this particular ion is having a bit more importance in the inorganic chemistry. This particular ligand is going to play a very important role in the brown ring complex particularly, that we will see soon while writing the IUPAC nomenclature. Okay, yes, so these are all. Actually, whenever you see NO2 as a ligand, we need to use the name nitronium, Cl chloronium, Br plus bromonium, and then so on. Okay, and then next let us move on to neutral monodentate ligands. Okay, so neutral monodentate ligands, just try to understand carefully. Yeah, it is simple. It is simple. In the previous two cases we have seen negative monodentate ligands, positive monodentate ligands. They are neutral monodentate. They will form one dative bond, but they are not going to carry any charge. So the monodentate ligands which carries no charge, there will be no charge on the particular ligands. Okay. So in that, the very important or very important one is H2O, that is called as aqua. Ligand name for H2O is aqua, and then NH3 it is amine, and then CO it is carbonyl. Very important. These particular ligands role is going to be very crucial in deciding any of the characteristic property of the complex compound. Okay, and then CS, it is thiocarbonyl. Just if you observe, NO, we have NO in positive monodentate ligands and also neutral monodentate ligands. Sir, how do we get to know? Okay, in case they will mostly give in the ligand form. If they give plus charge on the NO, then we need to consider it as a positive monodentate ligand. If no charge, generally we take it as neutral monodentate ligand. Okay, and then that is called as nitrosyl, and then NS, thionitrosyl, we call it as thionitrosyl. Yeah, this ligand is very important here. PPH3, we generally write it in a short form like PPH3, but exactly triphenyl, 3 phenyl rings will be there attached to a phosphorus, and don't forget phosphorus will have a lone pair also. Triphenyl phosphine, the name of the ligand is triphenyl phosphine. When it comes to EN, which is actually actually this comes in the neutral bidentate ligands. Okay, yeah, just try to erase this. Okay, yeah, EN, that is ethylene diamine, comes in the neutral bidentate ligand. Actually that particular En can able to form two dative bonds, right? Yeah, so we can able to say that En is a bidentate, neutral bidentate ligand. So with this I am going to end up with the video, but please make sure you follow the videos carefully, make sure you prepare your own notes, and now from the next video or from the next class I am going to provide my particular prepared notes in the form of written copies or maybe typed copies, and then I'll be giving you the link in the comment section or maybe description box, so you can able to download from there, or you can just WhatsApp me, and then so that I can able to transfer to your WhatsApp numbers also. So yes, we in the future we are going to see so many interesting things, so many, I am going to be the student favor, as you know already. Yes, I do different videos, I do more I put more effort to prepare all these videos, and then it is going to be some more. I'm going to take it to the next level from our next videos. Until that, please, if you're new to the channel, please don't forget to click on the bell icon, and then please do subscribe. Yes, you comment, you share, you just spread my channel to all your classmates, or maybe anyone, those who are preparing for competitive exams. Until that, see you. Thank you so much for watching the video.